Welcome back, guys. Today I'm going to discuss about Archimedes. In this Archimedes principle, two topics are very important. One is upthrust, second one is relative density. First, I'll complete the relative density topic, then I'll come to give the applications on upthrust. So, relative density, the nothing but the density of the substance by density of the water. Relative density of the substance, any substance. That may be a solid or liquid. That may be solid substance, may be solid or liquid. Then density of the substance by density of the water is the relative density. So this water at 4 degrees centigrade start to take. So that is another story. We will study later. So relative density of the solid. So relative density means you are comparing the density of the solid with respect to water. So water density is always, the density of water is always 1 gram by cc or 10 cube kg by meter cube. So this is good example in explaining the inertial dimensions n1 u1 equal to n2 u2. So there this is only will take as example. You come through first lesson onwards, means you are preparing for mains, you know this very well. So now what Archimedes stated, that the statement of the Archimedes principle, you see. So Archimedes principle state that the body of mass m partially or fully submerged in a liquid of density rho. So submerged in a density of liquid rho, some amount of mass is displaced. The mf amount of mass is displaced. So the weight of this mass displaced is equal to the weight of the liquid displaced is equal to the apparent weight of the blood, that is equal to upthrust. So your upthrust is equal to apparent weight, that equal to weight of the body in liquid. So that apparent weight is equal to weight of the water displaced. That weight of the water displaced is equal to mass of the fluid displaced into g. So which is equal to weight of the body in water. Weight of the body in water, apparent weight, both are same. That is equal to upthrust. So that which is equal to the weight of the water displaced. So your weight of the water displaced means the volume of the body, how much is immersed, that much water only comes out. Here the volume of this displaced liquid, the volume of the liquid displaced is equal to volume of the body immersed in liquid. So now we immersed into density of the liquid, means water into density is equal to upthrust, that equal to mg, means v into rho into that I will tell in the next topic. Now, so now consider W1 is weight of the object in air, W2 is weight of the object in water. So now the relative density is equal to density of the substance in air medium, that is equal to density means mass by volume. So mass by volume. So I can go with into g also will do by. So here how much mass is there? That equal to mass of this mass is equal to mass of the fluid displaced. So that is equal to apparent weight W1 minus W2 into g I will do by volume. Same volume will come out, right? How much is immersed, that much volume will come. So the same volume we have to consider here. Same volume of water displaced and volume of the body here. How much volume of the body is there, that much volume of the water is displaced. You have to consider. Okay, in relative density, finding relative density time. So now that equal to mg means W1 I can take, that is the weight in the air medium. Mfg means weight in the water medium, right? When it is placed in water, W1 minus W2 is called apparent weight in water. I hope you understand this. Relative density of the solid is equal to density of the substance in air medium by density of the water in when it is immersed, right? So now density means we know mass by volume. In air medium, mass by volume. In liquid medium, the value density is equal to mass of the fluid displaced by volume of the body. These two, the volume displaced by the water and here volume of the submerged part is equal. Consider that much water is equal displaced. But mass of the water or liquid and your mass of the body are different. So that is depends on density of the body and density of the liquid, right? Mass. Here how much volume is taken and this the volume of the body, that much volume of water comes out. That volume of water have different mass and that volume of black have different mass. So now here m by mf will come. We get a cancel. So multiply with gg, then mg by mf into g. So it is very clear. Mg means the weight of the body in air medium. Mfg means apparent weight in water medium, that is equal to W1 minus W2. So similarly, in the place of water, we will take another liquid. So now whenever comparing the liquid, density of the liquid by density of the water. So to find out the density of the liquid here, I will find out the mass of the liquid displaced into G by mass of the water displaced into G. So similarly like this. Therefore, this mass of the liquid displaced of same volume of the object in another liquid and mass of the water displaced by the same volume of the object will be different. So again, that it depends on their densities. That's why this ml into G is equal to apparent weight of the body in liquid, that equal to W1 minus W2. So m water into G is equal to W1 minus W2 in water. So this is relative density topic by the Archimede's principle. So according to Archimede's principle, it is giving the concept of upthrust and apparent weight, which is equal to weight of the water displaced or liquid displaced. So that can be written as V immerse into rho into G. Now one example we consider here to understand this concept. So consider a beaker of water. So in this water, let consider some amount, one volume of water part. This mass is equal to m. This part of the column, water column is equal to m mass, and its mass is equal to m. This is consider a part in the liquid container. So the same volume of black or wood or a cylinder, anything you can place here. So that means what? When you want to replace this part by any object, this volume should be empty, right? Because we know volume means the space occupied by the body. So volume means what? Space occupied by body. So here the wood material I am placing or any material I want to place means this much volume of water has to rise or it has to comes out. So that is only Archimedes is telling. So one story is there. Eureka, his king has given him that one question who will find out for them there will be a gift. Otherwise, he will going to hang. Like that one in Podiad he has given one question. At the time, all the scientists, his colleagues, means Archimedes colleagues and all, trying. One day when he is bathing, he finds that some of the water is flown out. Then he came to understand that. So why that mass of water displaced, that is equal to the weight of the body. So the volume into density of the body is equal to the volume of the body into density of the liquid into G. Means here weight of the body is equal to the weight of the water displaced. So then only we can swim in water. When you are displacing that much water from your under of your body, then only you can swim. That's why we will shake our hands, right? Hands and legs to displace the water. Yes. So I hope I'm going more examples, so it will be take much time. So now see here. So upthrust is equal to means this liquid is in equilibrium. That means mg is equal to upthrust. So the upward force that equal to the difference in the pressure into area. Pressure into area is equal to force. So P2 minus P1 into area is equal to upthrust. So V rho G. Here V is equal to volume of the body into density of the liquid into G, which is equal to volume of the body into density into G. So here density is density of the body replaced by this liquid. So these two are equal. This is the case. So this is the reason the small nail sink in the water, same material of the nail sink in the water, but same material ship made with more weight cannot sink. That means the ship is displacing more amount of water which is equal to its weight. But nail is not displacing because of its contact area, not displacing that much water, so it is sinking. So pressure is less on the surface by the nail. Sorry, pressure is more on the surface. So more force acting on the surface by nail, so it is going down. The same way, the ship is not like that. It is displacing the amount of water which is equal to its weight. That's why it is not sinking. Right. So let here V is equal to volume of the object and V immersed is equal to volume of the immersion fluid, V in. So coming into when the body sink, float, and what is the meaning of submerge and what is the law of flotation? Law of flotation. So when it will be float? So when the density of this means the weight upthrust is more than its weight, it will float automatically. The upthrust is more. So float means upthrust is more than mg. Means here submerge means upthrust is equal to mg. Sink means upthrust is less than mg. So upthrust is more means the density of the liquid is more than the density of the substance. So density of the liquid is more than density of the substance. So your density of the liquid is equal to density of the substance, then submerges. So your density of the liquid is less than density of the object, then it will be sink. So this is law of flotation. So next. So here, one thing you have to remember here, in the law of flotation, so somewhere it will come, but here I will complete. So volume of the ratio of volume of immersed to the volume of the body is equal to density of the substance by density of the liquid or water. So the ratio of immersed part of the body to its total volume is the equal to ratio of densities of body to liquid. Once again, the density of immersed or the volume of immersed one to the total volume of the body, the ratio of volume of immersed to the total volume of the body is equal to density of the body by density of liquid. Hope you understand? So this for why this ratio of densities also gives to you it will be sink or float or immerse. For example, the rho W is equal to means rho is less than D, the rho is less than D, then V in volume of immersed is greater than V, right? That means the volume of immersed is greater than V means the upthrust is going to be more, right? Then means sorry, upthrust is not means this volume of immersed part is more than volume is coming. That means so it is not clear here. It is not compared. So volume of immersion should be more, not possible, right? So this is not possible. Okay. So that's why it's sink, right? So now in one of the another case, so here something it is not giving the ratios are less means. So we already means densities ratio less or more means then we know it will sink or float or submerge based on the densities. It is clear. But how much volume rises, how much volume immersed or submerged? So volume of immersed is more coming according to this concept. So we'll see. So maybe that some other applications on come now, then we will get the clarity about it right now. See. So here there's a board carrying some piece of material initially. So now I'm going to now this is the level. Now this is the level of water. When boat is carrying the some piece of material. That may be the sinking material or floating material. The two things can be. Something are floating, something are sinking. So any one material consider. In one case, floating materials, in another case, sinking material consider. So now, so initially, the volume displaced by this boat is equal to the volume of water displaced by this boat is equal to mass of the boat into mass of the pieces by density of the liquid means water. So that is equal to this is the volume displaced by boat with pieces. So here this is the volume this m by rho is volume displaces by this m by rho is the volume displaces by pieces. So this is the volume displaced by boat. So it will be constant, right? Volume displaced by boat itself is constant, but volume displaced by the piece of material will be different for different material, right? Now coming into next case, pieces are dropped. If dropped pieces are floating material, example wood carrying boat, now we are dropping it. So now what will happen? The volume displaced by now boat and wood we have to find out. So now this is volume displaced by boat is constant. In the case of floating, when it is in the floating means mg is less than upthrust, right? So that equal to m means mass. Here upthrust means what is? So here volume into I can go with density of water into g less than. So this is get cancelled is 1. So m is less than v rho w. So m by b or m by rho w is the volume displaced. M by rho w is volume displaced by sinking material. So now this equal to the first. This is the first equation here. This is initial water displaced. Now here also same amount of water displaced. Second equation. So there is no change in the level of water when boat carrying floating material. Initial water displacement and the final water displacement after unloading water displaced by the boat and the pieces both are same. So no rise in level of the water in the beaker or in experiment, right? Right. The boat level will not rises. So now pieces are sinking in material. So in the place of boat, some other wood material you consider in a bigger experiment, right? In the river means you can't that much level rise or level you cannot tell. So there is no change in the level of sinking of boat. So now when pieces are sinking in material, sinking material I have taken. So now the water displaced by, so here you can see the water displaced by stones are m by rho. So they are sinking, right? So here the rho is density of material. The rho is what? Density of material, and this m by rho is the volume displaced by piece. The volume is equal to mass by density. Floating means it will be rho w. So now this m by rho, so rho is more than rho w. So rho density of the material is more, means sinking means what? The density of material is more than rho w. M by rho is less. Denominator more means the ratio is less. M by rho is less than M by the density of liquid water. So that means this total volume is decreasing. The volume displaced is decreases. So there is a sink will happen, right? So rise the water after unloading, the V displaced of the unloading is less than the V displaced initial value. Initial value is displaced is more when the boat is carrying the sinking material. So the boat is rises when they are displaces, and the displaces less water, right? So they are displacing less water means the boat will be more up, more it will come up, right? When it is carrying, the level of boat sink is more. Like that you can understand. The level of boat sinks more when it is carrying the sinking material. So these sinking materials are displaced from the boat rises up. So if you see a boat or ship is carrying from river to sea. So in the river one level, up to one level, the water is raised. Means it will be the part of the volume immersed is so some X centimeters height considered. When it is entering into sea, we know the density of sea is more than river water. The sea water is more than river water. River water means approximately 1 will take. Sea water is it will be 1.3, 1.5 like that will take. So more denser sea water than river water. That's why upthrust is more. The ship will rises, or you will feel that rising. Means now the depth sinked volume is means immersed volume is less in the sea than in river. So I hope this understand right. So here same this is only now. So here boat carry the material which are float material or sinking material. When float material means no rise, no sinks. There is no difference in the level. Level remains same. When there is a sinking material inside the boat, when unloading, in the case of unloading, the boat rises than its initial value, initial depth. It will be rise up. It will feel more upthrust. That's enough. So now, the next model of the problem according to Archimede's principle on the upthrust. For example, initially some volume of body is immersed in the water. Initially. So total length is equal to L means here let it be total length is equal to L. So in this, so L by some n parts, L by n part is immersed initially. So the volume immersed is equal to here L by n into A, the volume immersed initially. So now I am keeping some mass here. This mass without weight, that means this will be exactly sinking, means float submerged. The total volume is submerged exactly on up to the level free surface. How much mass is have to place on this block of mass m to be submerged total volume. So initially see when this is capital M mass. So initial case mg is equal to V in into rho g. V in is equal to rho into g. So when there is some mass I am placing, small m mass I am placing on this capital M. Now the total mg weight is equal to V into rho g. So here you can understand the upthrust is equal to volume displaced. How much volume of water displaced into its density, mass into mass of the fluid into density, mf, volume into density into g. So now 1 and 2 equations you are doing, you will get this answer. So the how much mass is equal to V minus V immersed by V immersed. So one example see. So V is immersed 30% of total V, that equal 3V by 10. So sometimes they will not give V, they will give the L by N, L by 2, half of the length, half of the part of the volume is immersed, like that they will give. So then this formula you can apply. The volume immersed in the place of volume immersed is equal to L by N into A. The volume is equal to total volume of the body is equal to L into A, capital L into A you can take. Or else some other time they will give percentage. Here in this example, percentage they have given. Some other time they will give cube of side. Cube of side L is equal to some 1 meter they will give. In this 1 by 3 meter is submerged initially. So that 1 by 3 meter submerged means 1 by 3 into A we have to take. A means L square into this is the volume into density of water into G is equal to initial weight. So capital M means M is equal to what I can go. If you know M means okay, M is not given means you have to go with L into A. This is 1 by 3, 1 into A into D into G. This is D into G. Now, how much mass you have to keep means here? M plus this M is equal to again 1 into A into volume into density into G is equal to total volume now. Again 1 into A into the rho into G here. So now A into rho into G will substitute, then M value will get. So that equal to M is equal to So here this 1 into A into rho d g is equal to 1 by 3. Therefore, 1A means rho g, A rho g take common. That equal to 1 minus 1 by 3. M is equal to. Okay, A rho g. Here rho is equal to density of liquid. If I want to change into D, again you have to follow another method, right? So now 2 by 3. See again, volume is equal to what? Length into area minus volume immersed means the immersed length 1 by 3 into area. Okay, na? By 3 into area. So 1 by 3 into area, volume immersed will come. Here M is equal to. So this is answer. So like that you have to find out. So these are the cases. Means the questions, way of questions can ask on this model of mass required. So according to given data, if you follow the same concept, you will get answers, right? So the way of solving steps will be different. Process may be different. By practicing number of problems, the process will become small. Easily you can step by step you can reduce and you can solve it. But formula and method is same. Process is same. Whatever the question related to this concept applied is same way. But approaching the process from the given data will be different. Remember, this is the physics, right? I hope you people understand. You'll understand. If you follow all my videos, you'll understand what I'm trying to tell. And the approach you'll understand how to solve the problems. However, the problem is giving for each and every problem belongs to same concept. Also, approach is different. That approach you have to catch. Which formula you have to choose. The right formula who are choosing, and the shortest answer will get. In mains, you people have to do within 1 minute answers you have to do. That case, you have to practice number of problems, number of ways, each concept. Then only you will get the clarity about that. Now here, so there is a one solid sphere of radius r, and mass density is changing. Rho r is equal to rho naught into 1 minus r square by r. This is changing from point to point, r to r, small r to capital R. So here the range. So the range, the density of the sphere is changing from point to point. Now is asking the minimum density of the liquid in which it is float. So now this one is floating. The sphere, solid sphere is floating in a density of liquid. So how much the density of that liquid should be to float it? They are asking density. So now float or submerge, the density of this the body is equal to density of liquid or lesser. The density of the body less than or equal to density of the liquid. Then only it will be float. Less than or equal to. So now first of all density, to find out density, mass by volume. So first mass I have to find out here. To find out the mass, so we know here mass is not given and density is changing, so we have to integrate compulsory. Therefore let consider a small element of the solid sphere. The density is varying from center to surface. So you take one small piece here, so which is how dm mass of the sphere. So then this mass of the sphere is equal to, okay, dm mass per volume is equal to, we will go with the density into dv, small dv, the density of material into dv. Here density is constant means m by rho will write into dv. That will be, density is constant means the dm is equal to m by v, you know. So now here, now integrating this dm, we will get m value from 0 to r. So density is substitute and volume is equal to here not 4 by, this is x radius if you are taking means the volume is not equal to 4 by 3 pi x cube. Remember this point. So volume of this one how to find out means the dv is equal to, so a small part dm means r plus dr volume you have to take, right? R plus dm or dr volume of this is the seat you have to consider. So then that is 4 pi into r plus dr seat na, for surface area 4 pi r plus dr whole square minus 4 pi into r square. So dr is small. So r square terms, r square also small here. R is also small. Dr also very small. Therefore r square terms 4 pi r square. But guys cancel means you will get 4 pi r square into dr. This is the answer will come here. Means volume. This is dv is equal to into again. This is the area into dr thickness. You will multiply volume you get. This is dA. R plus dr thickness into area, right? dv. So into again r thickness. So 4 pi r square into dr you will get. So where r is small now, that will be neglected, right? So now your constant term take out and integrate. You will get finally this is the answer 4 pi rho naught by 15 into 2 r cube after integrating 0 to r. So now density means formula already you know. So when it is when in which liquid is floating, that density I want to find out, that liquid of density I want to find out. Floating means mg is equal to upthrust. Okay. So now volume into density m is equal to how much 4 pi rho naught by 15 into 2 r cube. Now density of the liquid is equal to 2 rho naught by 1. This is the variation of density. Now next example. So here they are asking the extension of the spring in this model. So a weight is suspended with the help of string in a liquid of density rho. So then extension is how much is asking. So additional to the upthrust here, there is a kx also will be there, right? The compression in the string also will happen. So it is initially only mg is equal to kx. Mg is equal to kx initially. But now because of upthrust, the x value it changes into means something, some compression will happen, right? That is equal to here. So that means initially k into x is equal to mg. Now k into x minus some x dash. So this is equal to x naught I can take plus upthrust is equal to mg. So x minus x naught is equal to I can take as x minus that compression decreased length is equal to because of upthrust only that is decreases. So that is equal to x naught ampersand. So now present extension is x naught. So this is the equation. So you solving means you will get. And here length is given, area of cross section is given. Area of cross section contact with that to find out the not contact area. This is area of the cube, given cube or a block something. So that is it. So now we substitute now this is answer. Mg by k into 1 minus al rho g by 2. So no need to be asked like this only. They can ask in different way. So mg also you can change into volume into length like that, right? Here in the density will come here. So total here also in the place of mg take common here rho by rho I can write, right? Rho by d 1 minus rho by d I can write, but equal to mg by k if I take common. So here d is not there, therefore 1 minus the rho by d will come instead of that. So instead of this al into rho by 2m, right? But this is also one formula. Maybe they can give like this. So in extension by the string, the same E dash is equal to E into 1 minus rho by d. So this is extension in the Young modulus. Elasticity will study. Initially the extension is equal to delta E dash means E. Initial extension is equal to E. So now the same mass with the help of string or spin submerged in a liquid of density rho, then new extension is equal to the x naught is equal to this one, same, right? Right. So now next example. So here two liquids are there. So total length of this black is L1 plus L2. We know that is here according to given. L1 part is submerged in rho density and L2 part is submerged in 2 rho density. So this is in equilibrium means mg downwards, so total upthrust is upwards. So here don't consider upthrust means 2 rho density more, so upwards, so rho density less, so that's why it will be downwards. So therefore subtraction of upthrust is equal to mg. Never. Don't consider like that. Okay, upthrust is always upwards, whatever the density. Right? This liquid also upthrust to because of this liquid also upthrust is upwards only. Because of this liquid also upthrust is upward only. Therefore total upthrust is upwards by both the liquids. When it is density more or less. So one more application is there, water oil, one black is given. This will be at which point will be in equilibrium. So that model also there. So I have no time to take all the examples. I hope you people understand, right? So now after is equal to formula volume into rho g, you substitute means you will get this is the formula. Sometimes you will go L1 and L2 relations they will give. So L1 is equal to pi d by 4 and this is something, or this is 3d by 4 and d by 4. So then you can write 3d by 4 plus 2 into d by 4, 5d by 4 into rho. D by 2, d by 2. So d by 2 into d 3 d by 2. So 3 a rho g by 2. So like that. So in the place of L1 L2 ratio they will go. So that time this is. And here this mass is equal to what I can write here. The mass is equal to volume, that equal to L1 plus L2 into A into dz. So L1 plus L2 into A into G, this m. So when they have given here, see L1 plus 2L2. Here L1 plus L2 cannot be subtracted, right? A can be subtracted. GG can be subtracted. So then the ratio is given me, the ratio of density is d by rho, or density is equal to L1 plus 2L2 by L1 plus L2. So this is also answer. And they can ask, they are giving ratio of densities. So for example, how they will ask means the density of the black is, the density of the black is some times of density of liquid of first one, or some less some ratio of this one, like that they will go. This is related to rho, they will go more or less. From that L1 and L2 is how much part of the, how much part will lie in the first liquid or second liquid, like that they will ask. By giving this value, then L1 L2 will be simplified, right? The ratio of L1 L2 you can find. So that is also one more will come. Next example, very important. So there is a block of ice is there in the liquid, means in one liquid, any one liquid. Liquid can be water or any other liquid. Ice of mass m. So now this ice melts, it will become water, right? When ice melts, it will become water, and its volume, when ice melts, its volume is equal to m by rho w. When it is in the case of ice, mass into density of ice you have to take, right? Is equal to means volume of the ice into volume into density of the ice is equal to volume into the density of water into g. So these two are not equal, right? When values are equal also, these two are not equal, because it is, this volume is immerse, volume immerse is equal to. So now the total volume is melt, ice is melt. When ice is placing on any liquid surface, it will not fully submerge, right? Depends on its density, it will be, some part is outside the liquid, some part is inside the liquid. Therefore we in immersed I have taken here. These two are, densities are not equal now, therefore compulsory some value will be outside. Now when it is melt, its volume is equal to mass never be changes. When it is in the form of ice, it will be form of in water. Therefore mass of the ice by density of water. Now it is changing into water. So this is the volume required, or volume occupying by the ice when it is melting. This is the volume occupying in a liquid by the ice after melting. So now this ice melt in water. Ice placed in water and melt now. Then how much water it is displacing, the same water now also displaces. Therefore no rise, no fall. No rise or no fall. That will remain same. Because it is floating material now. In the above case I explained, floating and floating, no rise, right? Remains same. So now for example, the liquid I have taken here, the taken liquid is not water. So it will be lighter than water, kerosene or petrol, or coconut oil more density than water. So some other oil, which glycerin. So like that, the density is less than water. So now the displaced volume by the ice is equal to m by rho L. This is the displacing volume, because mg is equal to the volume occupied by the ice, density of liquid into g. This volume occupied is equal to total volume of the ice. Okay. Now, if you see, this is the volume displaced by the ice in the liquid of density rho L. Now, here already the condition is given, density of the liquid is less than density of the water. That means denominator less means ratio is more, therefore Vd is more, right? So m by rho L more than m by rho W. This is volume displaced by after ice melts. This is the required volume of ice. This is required volume m. This is the required value for ice melt. But here this volume is more than this value, means there's a gap, right? There's a gap between those two. So liquid will be, the liquid will level falls. There's a gap, that gap it will be filled. Surrounding liquid. I hope you understand this. Now density is more. Density of the liquid is more than the water. Ice melts means it required occupying value m by rho. M by rho is the volume occupying by ice after melting. M by rho L is the volume displaced by the liquid when ice there in a liquid. Right. So it will be less because rho L is more. Denominator more means the fraction is less. Denominator less means fraction is more. So I have given symbols. So liquid level falls, rises. The more displaces. Ice displaces more water than it required. Less water than it after melting. That's why the water will be occupied some surface, some level. Means ice have some more volume now than it displaces in the liquid. So after melting, some water will be occupied on the surface. So level is rises. In the above case, when density is less means it displaces more. But after when ice put, it displaces more water. When it melt, less volume. In that case, the remaining water come and occupy that gap. So falls. The level falls. So that is clear. So next model on this application, and it is related to rotatory motion also. So torque equation you have to use. That's why equilibrium, NLM, torque. Now see here 2 steps you have to follow, very important. First one is applying the forces. And we know the torque equation about any fixed point or center of mass you can apply. Either mg, either buoyancy, or at the point B. About the point B you can apply torque equation. About the buoyancy point you can apply the torque equation, or mg. About mg you can apply the torque equation. First step is you have to apply the torque equation for equilibrium. Because I don't know how much force acting at P, and I know the buoyancy value and mg value, that's why I will going to apply the torque equation or equilibrium equation about the point P, I will take, because I don't know the value of P. Let it be. So here the question, next one, first torque equation you have to apply. Next, when you are applying the torque equation, some perpendicular distance values we need. For that, what we will do means, so here the length is immersed. This length, green color and red color I have given, see colors. This is the length immersed here. The total length is not immersed in the water. So the buoyancy will act at the center of the immersed part only, but weight is center of the rod, total rod. You understand? The weight is center of the total rod, and buoyancy force is only center of the immersed length of the rod. This is over. Now we have to find out the, for example, m is given. M is the mass of L length, L centimeter. So now m by L is the mass per of 1 centimeter unit mass. So now m by L into L is the mass of L centimeter. Means this is the mass immersed in liquid of the rod of the mass. This is immersed length in water, that mass. Now, first of all, we will ask to find out the length. Sometimes we will give theta, and we will ask to find out the length and buoyancy force or some other questions. So here is given only L by 2 here, this length, how much level water is filled, and asking theta. First of all, theta is asked. So here for finding the theta, sin theta, opposite side is there, and I put in this side, I have taken as small l, red color small l. Therefore, sin theta is equal to, I will get L by 2L. Sin theta is equal to L by 2L. Now, according to concept, torque equations, next. So here V immersed, volume of the body immersed, area of the contact into L square I can take. L is the part of immersed. So apply means capital L is equal to L into root 2. So this one substitute here, you will get sin theta is equal to 45. Theta is equal to 45, sin theta equal to 1 by root 2. Over. So now here, asking the force at P. Next question, they will ask the force at P. Theta is over, and after theta, how much length is suspended or Small L value you can ask by giving the L value, all those things clear. Now, the force acting at P, or this is the pivoted point, how much force is acting, they will ask. So here you have to consider first of all, the force acting on this one, normal force only, that is upward or downward. That is our question first. The normal force means here I have to do B minus mg or mg minus B. So which is correct? Which is correct? For that purpose, B value, buoyancy force find out, and mg value find out. It is equilibrium means these two should be equal, right? But not equal here. So buoyancy is more than its weight, right? Buoyancy force acting on this length of the rod, immersed part, on the immersed part due to this liquid is more. But it is given in equilibrium of length L immersed, and it is in equilibrium. That means the reaction force acting downwards. The force at this pivoted point is acting downwards. So now apply the equation N plus mg is equal to buoyancy. From that I will take the reaction acts downwards. So for that clarity, I have explained here. First buoyancy I have to find out and mg I have to find out from that. So this is. Then after solving, we'll get answer this. Similarly, next model. So here values are given. In this case, values are given and asking to find out the how much weight. Here see another model, weight is suspended here. How much weight I have to suspend. So 5 meter of length out of 6 meters of rod, 5 meter placed in the or immersed in the water to place 5 meters. Okay. So now same first torque equation. Before that theta is given already 37 here. So no need to worry then. How theta is given here 37 means 3 and 5 is given, therefore 37, and anyhow all the values will be cancelled here, no problem at all. Theta is, we can say, independent because torque equation means perpendicular distance. This length is only important here, how much length only. Cos theta, all our perpendicular distance are same, cos theta terms only will come. So all cos thetas get cancelled. In that you can check once. So mg into L by 2 cos 37 plus W into 6. W, for W it is the 6 centimeter length, for W perpendicular distance. For W, this is 6 cos 37 is equal to buoyancy. So buoyancy is how much? First to calculate. So buoyancy is equal to same mg, right? M of the immersed part means m of the fluid into g. So this will be volume or m of the rod immersed. So for that, this calculation 6 kg, 6 centimeter or 6 meter length is 12 kg. Each meter is equal to 2 kg. Then 5 kg, 5 centimeter, 5 meters is equal to 5 into 2 kg, 10 kg. So now 10 into rho into g. So by density. So density of the rod is given, half of the density of, so here given density of the rod is equal to 0.5 is given, that is equal to density by 2. So now we'll substitute, this is 20 g will come, buoyancy force, right? Right. So now mass, buoyancy force is equal to mg, right? Mg is equal to v rho c. Here volume is equal to mass by density, you have to follow. So mass 10 kg by density rho by 2 into rho into g, right? Volume into g, right? By that buoyancy is equal to 20 g will come, 20 kg. So now this buoyancy here apply, and here length is equal to 5 by 2 means torque na 20 into 5 by 2, that equal to 50 g minus 36 means 14 g. Therefore the weight required is equal to 7 by 3 kgf. 7 by 3 kg weight, kg force. And here we need to find out the force at the point P is downward or upwards. For that, same calculation. Buoyancy force how much? 20. Its weight is equal to 12 g downwards. And it is 7 by 3 means less than 2, means more than 2. 12 plus, it is less than 15 only anyhow. So buoyancy is more, normal force acting downwards. This is clear. For normal force, mg and weight downwards, buoyancy alone upwards. So buoyancy minus, so these two. Okay, minus these two. So you will do mean 17 by 3 kg. So these are questions related to Archimedes, upthrust, and relative density. There are many models are there. So as I said earlier, concept is same. The model of the problem is different. We have to apply. Thank you all. Thank you.